All right, today we are on lesson 2, points, lines, rays, and segments. So today we are going to draw points, lines, line segments, and rays. Before we start, your book should be, your book should be closed. I shouldn't see anybody starting. Michael, what did I say? Okay, so before we start, this right here is a point. A line does not have any points on either side. It's just a line. It goes on forever in either direction. A line segment is a part of a line that has 2 end points. We would call this right here an end point. Okay. And then the last one we need to talk about has a point, a line, and an arrow. That is a ray. Everybody say ray.
Ray.
Okay, most often we see a ray when we're looking at angles, because angles are made up of, oops, it did not like how I draw. Unpause. Okay, so that is what we're going to do today. Now you may open up your book to page 6. Okay, and I'm going to give you a minute or two. Find the value of each expression mentally. So you're going to try to do it in your head and write down your answer. All right, raise your hand. What is 90 minus 45, Aaron?
45.
This thing not working? 45. And what is 270 minus 45, Gage?
225.
225. Yep. And what is 270 minus 135? Riker.
135.
So then what is 360 minus 135? Brett.
225.
225?
No, I want to say that's wrong.
I think that's going to be too little.
Yeah.
But you're on the right track. Keston, what'd you get? 245?
Kind of just a guess. But yeah.
Ah, it's close. All right, Quinn?
235.
Let's see. That'd be 370. So I think you're close. Kara?
255. No.
Too high. Delaney? 225?
Yeah, that's what I said. Yeah, that's what Brooke said.
Oh, it is?
Yeah.
Did I write something else down?
No, you
Oh, we just thought it looked too low. Let's add it. Let's add it and see. Let's check. I think you're right. It just didn't look right to me, but you were correct. Good job. So Brooks, and then who else? Delaney. Nice job. Who else got 225? All right. Pat yourself on the back. Guys, what do these expressions have in common? Kaylin. I noticed that all the first numbers are multiples of 90. What else do they have in common, Vivian? They all, yeah, the second number, they all have 5s, right? And their answers. Okay, what else? Michael.
I noticed that they're all multiples of 45, all of them.
Multiples of 45. Isn't that interesting? Okay, Cora.
Well, I just spotted this out. But one and then the third one, they both answer the same number that's in the problem.
Oh, okay. All right, last one, Jace.
That they're everything, all the numbers are multiples of 5.
Multiples of 5. So, how did your first observation that the first numbers are all multiples of 90, how did that help you guys find the differences? Remember, difference is the answer in a subtraction problem. How did that help you find the difference? All right, so moving on. Okay, close your books, but mark your spot with your pencil.
Okay.
We're going to get started with activity 1. We used many different words yesterday to describe figures. We learned how to identify points, lines, and line segments, right? We're going to act out each term with arms and hands. We are going to continue to define points, lines, and line segments in this next activity. And you are also going to use some cards to define another figure array. Okay, so, all right, that was fun. Okay, so today you are going to be starting with a card sort. Okay, listen. You are going to work with your math partners. So you each group gets one paper. First, you're going to cut them out. Then you're going to sort the cards into 4 groups. Each group should represent the attributes, which means characteristics, right, of one of the geometric figures. Pause for directions from your teacher before completing the graphic organizer. Okay, so I am going to read you guys the definition, and then we can talk about what goes there. So a point. Oh, these are the answers. I am usually represented by a dot or a circle. Did we all figure that one out?
Yeah.
Okay. I have no size, no width, here's the key word, no length, and no thickness. That is also a point. And then also you should have this. Oh, I turned it off. You should have this. A big dot, right? Okay. Line. Are you ready? My length can't be measured. I have no start and no end. So a line, if it is just a line, it has no end point. Okay. I am a set of points arranged in a straight way. I extend indefinitely in 2 directions. That's also a line. Infinite. I often have arrows to show that I keep going in 2 directions. So you should also have this symbol. Okay, ray. I am a line that is bounded by 1 point but goes on in the other direction. My length can't be measured. I have a start but no end. Because that arrow means it goes forever, right? Okay. I often have 1 dot and 1 arrow to show that I go in 1 direction. And it looks like you should have done this one. Okay, next we have line segment. I am a part of a line that is bounded by 2 points. I have a specific length. I am often shown with 2 dots or with no dots.
Wait, what? Oh, it can't have no dots?
With no arrows.
I'm guessing that they mean this. Like when we do parallel lines, do you guys put dots?
No.
Yeah, that's probably why. Never really thought about that before. So it says I am often, so it doesn't have to have 2 dots. It could have no dots.
But if it has no dots, it's a line segment.
So here's the thing. It would go on indefinitely and be a line if it had the arrows. So what they're saying is if there's no arrows and it's just like that, line segment.
Or it could be a line.
Cannot be a line. A line would have to have the arrows. According to their definition, I often have arrows. So I don't know.
Then, if that's a line segment, these would be parallel lines.
Yeah.
So, but
It'd
they
be,
would
oh,
cross.
parallel line. That's why it says often. No, those are not parallel. Parallel never ever
I
touch.
know, but them saying that.
You lost me, Brooks.
Okay.
Okay, we're going to move on. All right. I'm not saying you're wrong. You just lost me. Okay. So, which cards did you guys spend the most time debating as a group? Gage. Which card?
Just forgot.
Okay. Okay, Coral.
I am a location.
The I am a location. So try and figure out the point. Guys, should be quiet over here. Okay, Cade.
This one, I have no size, no width, no length, no thickness.
Yeah, that one was confusing me too. But we figured out it was the point. Because it has no length, and a line will always have a length. Chase.
Me and my friend are actually argue about it.
Okay, good. You guys know your geometry. A point might be tricky to think about. It is often represented by a dot or a circle, which could be large or small. But the point itself cannot be large or small since it only marks a location. Something to think about. What about a line? Why can it not be measured? Why can't you measure a line? Hadley.
Because if it has the 2 arrows, then it keeps going on like forever. And then if you can't then you won't be able to.
Guys, pull it together. Yeah, so it would have to be a line segment for us to measure it. Otherwise, it's just going to go on forever. Why is a ray also impossible to measure? Aaron.
Because it has a start point, but it doesn't have an end point because it's the arrow at the other side, so you cannot measure it, even though somebody could go, oh, you can measure this because it doesn't have 2 arrows,
Charlie, sit down.
but you actually can't because it's got 1 arrow in the direction. It's impossible.
Yep, you got it. All right. Activity 2. So first of all, you are going to throw away, not right this second, but in a minute, you're going to throw away your card sort. Okay? I don't want to find these cards laying around the classroom. Activity 2. Each dot on the grid represents a point. Draw line segments to create a triangle, a rhombus, a trapezoid, a hexagon, a pentagon, and a rectangle. How many sides does a triangle have, everybody?
3.
How many sides does a rhombus have?
4.
A trapezoid.
3, 4,
A hexagon.
6,
A pentagon.
5,
Do you want me to leave them where they're at till Jody takes some of them too? Or do you want me to send some, they're working on, we're done with math. They can just come in and sit as long as they want. Does that work?
Yeah, they're totally fine.
Awesome.
We'll figure it out. And a rectangle is how many sides? 4. Okay. Due to the fact we're running out of time, this drives me nuts. A rhombus is a square. Usually it's turned sideways. So it's just tilted. All 4 sides are the same length, but it does not have... All 4 sides are the same length, right?
But
Rhombus.
we're just drawing right shapes.
I think it still has to have right angles. Are those right angles?
No, a right angle is.
I am having a brain fart. So a rhombus has 4 equal sides, but it does not have to have 4 right angles.
No.
A square has to have both. Okay, nobody should be getting up. I don't know where you're going. Turn around. Sit on your bottom. Gage.
Could you call it rhombus diamond?
Most people know it as a diamond. Guys, just find a spot to sit. And we are still doing math. So find a spot to sit. Okay. Then, eyes are up here, McElroy. Gage, that is the exact opposite of what you should be doing. On your bottom so everyone behind you can see. On your bottom. Keston cannot see. Thank you. Okay, for number 2, drawing a combination of rays and line segments. You're going to create an uppercase letter, a number, and a lowercase letter. And then we're going to synthesize. Is that it? Okay.
Wait, that's a trapezoid.
That's a parallelogram. Trapezoid is this one. Hey guys, if you're stuck, remember a trapezoid has one side that's shorter and one side that's longer, and then a pair of lines that would intersect if you extended them. Okay? If you have a question, come here.
How would you draw a sided shape like that? With that one?
Well, they all have to have the same length, each side. 1, 2, 3, I think. Oh, I guess. Guys, it does not have to have each side the same length. Erin, never mind. Okay. Guys, you don't have to show me. Go do your cool down. When you're done, do your cool down.
How do you draw 5 sides, right?
I just did one right there.
Oh, okay, thank you. Okay.
Yeah, do your cool down. You go. Guys, stay focused. We've all seen rain.
This is a hexagon pentagon.
It's got 6 sides, so it's a hex.